Well, hello everybody and welcome back to the bench. I thought I'd take a little break from all the stereos and receivers and things and go to some basics here. I bought a whole box full of these old radios from a antique store that was moving to a new location, and they were kind of blowing out a lot of their stock. And I bought a whole bunch of these, just different kinds of old radios. I think the most I paid for any one of them was $6 or something, so I don't have much money in them. And I thought I'd take a look at this one. I also did a video on recapping receivers, like trying to answer some questions and things that I get from a lot of you. And to me, frankly, the video just turned out kind of lousy. I don't know. It didn't have good flow to it or anything. So I may have to reshoot some of the footage on that, or I'm debating whether I want to post it or not. So anyways, just kind of decided we'd do something simple and fun for a change here. So this here is a Motorola, and I didn't even look at what model it is. It's a model BT16BN, and it is a vacuum tube, and it is actually AM and FM. And if you look on the top here, one of the problems is no FM. Now, I've never even plugged this in. I don't know if it works. Don't know a whole lot of anything about it. But I thought, well, let's bring this up on the Variac real slow and just see if we can even get it to work. So let me get it connected up to my Variac, and let's see what we can get. Okay, I have the Variac dialed up to about 20 volts. Let's turn the power on. Ooh, that's a real stiff knob too. And we're not drawing any current whatsoever yet. So let's just bring our voltage up a little bit and see if we get anything. Oh, it jumped a little bit and then went down, so there is a capacitor or something in there. All right, let's let it sit there and cook. I got about 65 volts on there right now. Let's go up a little bit more. I'm not getting any real big current draw. All right, we're up a little bit more. Looks like, yep, I hear something. Okay, so we got some noise. Well, that's good. So, I guess we have some sound, so let's switch over to FM and see what happens. And just like they said, no FM. So let's take it apart and see what's going on inside. All right, here's a pretty interesting little design of a radio. So you can see here's the main chassis, and here's your IF cans, filter capacitor, your tubes. But if you look, the FM section is a totally separate chassis. It has its own, you know, there's the, believe the discriminator tube, I would say, not sure. Your tuning capacitor for both AM and FM are attached to it, and then you can see your coils up here. So yeah, this is a pretty interesting design, but I can also tell you probably want to go ahead and look at online and see if we can find some documentation for this to see where we can inject some signals to see if we can find out why the FM is totally deaf. The other thing I noticed is while this was on, it was increasingly getting louder hum. Now either that's because a capacitor is starting to fail, or we could have the dreaded silver mica disease in one of these cans. Could have a tube starting to go bad, getting grid leakage when it heats up. So we'll see what we can find. So let me go online and do a little bit of searching. Well, a quick little search on the internet turned up this little schematic, and it's really going to be all we need, I think. Of course, I don't have any alignment, information, but I'm pretty sure it should be pretty easy to do. So I was wrong. That tube up there in the front was actually the RF amp and converter for FM. This is your FM section in this little dotted line. And if you look, the actual discriminators are solid state. They're 1N60 diodes. And they also are using a diode rectifier, which probably on this is going to most likely will be a selenium rectifier, but we'll take the chassis out and take a look at that. Not sure. The fact that the AM works tells me that all of this section in here, at least this part around here, is all working. So we can check in here, and really the first place I want to check is over here. So to see if right here on this terminal 1 and 2, if we're getting any output, if I put something on the input here from the signal generator. So one of the things that can cause these to go deaf would be if these capacitors are bad and you're getting a lot of AC and a lot of noise and interference on here. That could really mess up your voltages and things and cause it to quit working. So before I even get into that, I want to get rid of that bad hum and make sure that we don't have any capacitors that catch fire on us while we're testing this thing. So I'm going to pull this bottom chassis out and check the capacitors and see if any work's been done on this radio. And if not, we're going to go ahead and at least fix the power supply capacitors, the filters. Well, we have the chassis out now, and judging by the looks of this, everything looks to be pretty much stock. Maybe there's been some soldering done on the main filter capacitor, and if you look, let me get a little pointer, if you look right in here, it looks like this this center's starting to pop out on this cap. So it's probably just about shot. Don't know about this one here, but it certainly will need tested if nothing else. Everything else, I mean, if you look at it, I don't see any components that could, mostly ceramic disc capacitors. This looks like a death capacitor here. That'll have to go and be replaced with a safety cap, because this is your incoming line. You see it comes right out of here, goes through two resistor, through a fuse and through a little dropping resistor, and then the cap goes across there, and then we go right through the here's your diode, and it is not selenium, it's a silicon diode, or maybe germanium, but I would say silicon. And there you go. So not a whole lot to replace in this radio. It should be a good radio. These are the old possibly foil capacitors. I don't know, but they don't look to be bad, but we'll check them out. I don't think they're bad. So I think just a couple of filters may need changed out, and we should be good. So let me do some testing and let's see what we get. All right, we got some schematics here. Let me put my microphone on so you can hear me. And if you look here, I was kind of wrong about a few things. First of all, this thing, the discriminator is not a vacuum tube discriminator. It actually uses little diodes, and these are little 1N60 germanium diodes for the detector, or for the discriminator. And this front end here, right here, this dotted section represents this metal can up here, like this separate section, and this is your FM tuner section, or at least the front end. It's a little RF amplifier, and you can see the FM comes out of that through this little coax cable here, if you look, and into pin 1 of this 12BA6, which is your first IF. And what we're going to do right now, let me see here, is we're going to do some quick tests just to see where we're losing our signal and if we're getting any signal to begin with. The first thing that I'm going to do is I'm going to take this little spiral coil of wire that I made. This is just stiff single conductor copper wire, and I'm just going to place it, if you look over here, right over top of that tube. Now this tube here is kind of interesting. It's called a 12DT8. 12 meaning it's a 12 volt filament. But the thing is, if you look at the properties of the tube, it's a dual triode, and it is almost identical to a 12AU7. The main difference is pin out is almost the same. The main difference is that pins 4 and 5 are your filament, whereas on and pin 9 is a shield to make it low noise. Whereas on a 12DT8, or I mean on the 12AU7, pins 4 and 5 are the filaments once again, but pin 9 would be a center tap of the filament. So if you were to just plug that tube directly in place of this, you'd be shorting your filament directly to chassis ground, which is not a good thing. So you can technically modify the socket and put a 12AU7 in here, but number one, it's not low noise like this, and number two, you would have to modify the socket. Just a little information in case you wanted to know. Now, the first thing I'm going to do is, in order to do this test, you'll need a signal generator that can do FM modulation, not AM modulation. You can do this with an unmodulated signal, but it's a little more difficult and a little harder to hear and things. But if you do have an FM modulated signal generator, the first thing you can do is let's just put a channel in there, set it to a station, and see if we can tune it in. So what I'm going to do is I'm going to connect the positive lead of my signal generator to that coil, to one end of the coil of wire. The other end of the signal generator is going to go to chassis ground. So far so good. And I'm going to turn this thing on, and we're going to listen to see if we get any kind of output. So I've got to wait for it to warm up. Hopefully nothing's shorted in here. And I'm going to set this to just mid-range, so let's go like to 98 megahertz. Okay, so right now I'm set to 10.7 megahertz. And you can hear the signal coming through the tube. 10.7 is your IF frequency. Okay, and we're not going to talk about how IF works on this video. You can watch some of my other videos that I talk about intermediate frequency. But as you can see, at 10.7 megahertz, regardless of where I tune this, although I got some noisy, some weird stuff going on, it is coming through. Now, if we go to, let's say, where a normal broadcast station would be 98 megahertz, okay? You can hear I don't have any sound, just static. And if I tune through this, somewhere I should be able to pick up my 98 megahertz. And as you can see, I'm not getting that. Now, let's talk about that for a second, because if we can pick up our IF frequency, it passes right through. So we look down at our little schematic. If our IF frequency of 10.7 megahertz can pass through all this circuitry and get to here, and then pass through all of this and get all the way down to the speaker, we can have a pretty good idea that all of this is working for FM. The place that we're losing it is where we're taking that FM signal, tuning it at the front end, and then stripping it down into an IF frequency. So that circuit that does that is called your RF amplifier and your local oscillator, and obviously something in there is not working. Now, let's say we couldn't get anything through there either. Here's another test you can do. So we're going to go back up to our signal generator, and I'll just show you real quick. I'm just using this one that I use in most of my videos, and I'm going to set this to frequency 10.7 megahertz, which is our IF frequency. And I have about a medium strength signal. It's negative 40 dBm. And if I turn this on and I just take a little capacitor, it doesn't really matter what kind. This is a 0.001 microfarad, just to add some isolation. You can see it, just hook it up like that, and I use this as a little probe now. And if you take, right here's where it's going in, and if you look down here, right here's where we're coming in at, our first IF. That coax cable is this little dotted wire right here, and you can see it going in there. If I take and I touch this right to here, that's going to put a 10.7 megahertz modulated signal with 400 hertz tone modulating onto it, FM, into this circuit, and technically I should hear the tone. I should hear my 400 hertz tone. So you can see I don't even have to touch it, just getting close to it, and when I touch it, you could see. So we know that this whole portion of the radio is working on the FM, and we've now narrowed it down to here. Now there's a couple things that could be happening. Number one, our local oscillator circuit could not be working, and that could be due to a faulty component in here somewhere around in this front end, or it could be the tube itself is not working. And the reason I think it's the tube, could be the tube, is because this tube is very, if you tap on it with the volume up, sometimes it just kind of goes crazy. It makes all kind of noise, like there's an internal short or something going on. The other thing is, I don't think it's silver mica disease in the IFs, because the IFs all work fine. So it's something in this front end. Now, there's a problem with this particular model of radio, and we'll get into that here in a second. Alright, I'm looking at the front end of the radio, and you can see the tuning knob here. This is the dial. The dial face would attach to this, and here's your tuning string, and on the back it goes through this metal, like this metal canister here, this little square canister, and you can see the shaft goes all the way through that canister and goes on to the tuning capacitor as well. Now this is kind of a little bit of a different design in this tuner, and that's one of the things that was interesting about it to me, is that if you look, it uses that tuning capacitor back there, okay, and again, I might be saying this wrong, and you guys jump in there on the comments if I'm wrong on this, but you can see, let's see, you can see the capacitors right here. Here's your two capacitors, and these represent these two capacitors right here, this right here, this tuning capacitor. You can see 1 and 2. Sorry, I'm out of shot. 1 and 2. Now, also though, if you follow, there's a dashed line. This means that these things are all connected together. You can see this one's connected and this one's connected. And then when we go up here, you can see it's also connected to 2 coils. So this is a coil-tuned FM section. And this is similar to how a lot of the car radios and so forth will tune, and the old style FM radios. We call this slug tuning. So probably inside this can over here, you probably have some sort of a mechanism that's running, running a ferrite slug in and out of 2 coils. And that's where your FM tuning is taking place. And you can see there's a cover here on the front of this can, right here, and you can kind of pry it open. There's a place to pry it off. The problem is, if you look at how this thing's assembled, this metal cover goes behind this, and you can see this connects to this plate, which connects to your tuning string. So what's going to happen is, and you can see that whole mechanism here, there's a hole in this front cover. You can just see it down in there. And this shaft goes all the way through that. So the only way to get this cover off would be to completely disassemble this, take the dial string off, which we all know how much dial string winding is miserable, and then take this set screw out, take this whole dial off, then take these screws here out and actually remove this can from the back, and then pop this cover off to get in and work on it. And you can see what this just really wasn't meant to be serviced very easily. And if you look inside of it, what's in there, there's not much in there to break. So you can see there's one little diode, some little tiny value capacitors that are probably ceramic or mica. They're not going to be foil or paper capacitors that go bad. There's some resistors, and you can see they're 10% tolerance, so they're pretty decent resistors. And the vacuum tube itself. So really, unless you're pretty sure that there's a bad capacitor in here, you really don't want to disassemble any of this. And that's why, again, just kind of using a little bit of reasoning, I think this tube is bad. Now, here's the problem I'm going to run into, and that is I checked all my stock, I do not have a 12DT8 tube. And even if I wanted to retrofit this with a 12AU7, I would still have to be able to take this whole assembly apart to be able to do that, and then you run the risk of noise and everything else, because a 12AU7 really isn't made for this, even though I've seen 12AU7s in this position before, but they always have an aluminum shield all the way around them to shield them off. This one really just has the shield up to here, and that's probably why they're using the actual 12DT8. So I'm going to just do a quick test of the tube. I have a feeling the tube in a tube tester will test good, even though it's bad. And this video might be on hold a little bit, because I looked online, and to buy one of these tubes, the cheapest one you can find is about $8 plus shipping. And I really only have $4 or $5 in this whole radio, and I really don't know that I want to put $12 or $15 just in one tube in here. So I may have to wait till I come upon some of these for a good price, or get some old scrap radios that have one of these that's a good tube. I don't know. But let's poke around and look at a couple more things that we can do. Check the AM and make sure it works. And worst case scenario, this will be an AM radio until I can get that tube. Alrighty, we got the old emissions tube tester out. Old reliable. I've had this thing for, I bet you I've had this thing for over 30 years. I bought it at a flea market for like $5, and it has tested so many tubes over the years. I cleaned it up and rebuilt it once. It still has that musty old test equipment smell, but you know, it's an old friend. So let's turn it on and let's just at least see if we can get some emissions out of this tube. Again, I'm going to think that it's going to test good, and sure enough, there you go. So you have pin selector number 2. There's 2 elements, remember. So there's your first element. And then we're going to switch over to number 7, turn it back on, and of course the tube reads just fine. And if we check for shorts, number 5 is going to be the only one that's going to read false. And there's number 5, and you can see it's lighting up, reading false. But we don't have any shorts anywhere else. So let's let this run for a little bit, give it a few seconds. But again, the tube tests good. So what does that mean? Well, it means that the tube could be good and something else inside that module could be bad. Or number 2, the tube is bad, but we're not seeing it with this type of tube tester. There are different types of tube testers. This is the simplest one there is. This one doesn't even have a grid leakage test. It strictly has emissions only. So, you know, and it doesn't apply the voltages or currents that you would see in the real world. So this is really just the most basic go or no-go test you can make on a vacuum tube. You certainly can't use this to match tubes or anything like that. But at least we know that there's no shorts in the tube, and we know that the tube is actually conducting or has some emissions on both elements, both of the 2 elements. And you can see when we tap it, it doesn't seem to change anything. And you can see here, looking. That's just dirt on the socket there, you know, moving it around, but you can see it's pretty good. Well, I don't know, maybe not. It's jumping around a little bit. And if you notice, when this thing heated up, that's what it was doing, is we were getting like fading in noise coming and going. I don't know. Again, the tube could be bad. The only way to really test it would be to get another tube and try it. But you can see it's kind of warbling around there a little bit. And I'm not moving anything. So who knows? So that's noisy there. If we go back to number 2, let's see if it jiggles around. It does too, a little bit. So who knows? Anyways, there you go. Now, also some fluctuations in the incoming line voltage and things can cause stuff like that too. But so again, not sure. All right, I just got to ask you folks: do you ever try to get out of your car, out of your automobile, and forget to take off the seat belt? And you know that feeling you have when you first try to stand up and then you feel the tug of that seat belt that you forgot to remove? Well, I just went to put that tube tester back and forgot to disconnect my microphone. As you can see, I use one of these little clip-on microphones on my shirt like this. I think it just helps the sound a little bit better. And sure enough, I went walking off with it and about hung myself with it. So yeah, you see, that's the kind of stuff you get when you watch a person like me. Okay, so anyhow, here I found something really fascinating in this radio. I have never seen this before. If you look here, once again, we were talking about these 2 coils, and you can see they're tapped coils, and the center tap is, moves. And I thought these were slug tuned, and they are not. this is actually a tapped coil, and look how they do this. Yes, I cheated a little bit. I bent this out a little bit because I just don't want to have to tear this thing apart. But let me zip you down in here a little closer. This is really cool. If you look down inside here, can you see it? Now watch when I turn the tuning. You see that little thing moving around in there? You see, there's a little set of contacts, almost like a wiper on a potentiometer. You see it moving around in there? Right there? And see those little tracks? It's really hard to see, and I apologize. But see there, these tracks? Those are actually spiral wound traces etched onto the PC board. And when this tuning knob rotates around, okay, you can see, this tuning knob rotates, that wiper moves around on that little spiral coil that's printed onto the board. So it's a PC board inductor. It's a printed circuit inductor, and it's acting as a tapped variable coil. And that's just fascinating. I have never seen anything like that before. And that's how they're deriving your oscillator frequency. And you can see here's your converter tube. So this is going to be your local oscillator for FM. And you can see here your two coils, your two tapped coils, and there's two fingers that go around that circuit board and tap that off. Isn't that neat? So really, looking inside here, there's not much of anything to go bad, because that's really just a circuit trace. So I'm kind of glad I bent that cover open a little bit and looked inside. I've never seen anything like that before. Now there are other things in here like these little coils and so forth. I have to assume, I don't know, they don't look like they've been tampered with. The only thing I can figure is either this tube still is bad, which I don't know, or these coils have been tampered with somewhere and it's no longer, I can see that like this one here has been really bent pretty severely. Let me see if I can show you that a little closer. There's a coil. Boy, it's hard with all the lighting here to get this. See down in there? That's a coil. This in here is a coil, and the way you fine tune it is by bending the windings further away or closer together from one another. And it looks like this one's really been bent quite a bit. Both of them have. That might be necessary. But again, if somebody reached in there and bent those, it will throw your whole oscillator section out and throw your frequency way out. So, yeah. So now we got to figure out why the local oscillator isn't oscillating. And if we can do that, I think we're going to get our FM to come back. And I really don't think we're going to have to tear into this unless something's really, I just can't see anything being bad in there. But we'll check it. So let me do a little more poking around and I'll be back. Alright, I think we've gotten somewhere. If you turn this on, I'm set to about 88 megahertz and I'm at the bottom of the dial scale. And you can just barely hear it, but watch what happens when I wiggle this tuning slug. So I think what you're seeing is that probably those little fingers in there are dirty. Now I tried just spraying a little bit of contact cleaner in there and working it back and forth, but it seems to be more than that. And what I'm thinking is possibly one of the little circuit traces or something has a crack in it and is causing all that. Unfortunately, the only way we can fix that is to remove the dial and to take this front apart and see if we can get in there to fix it, which isn't very desirable to me, but I think that's the only way we're going to get this fixed. So let me think about this for a minute and see how we can get this apart And I think we're going to find the problem inside there. Well, I took the time and took this thing apart, and I'm thinking I found the problem here. If you look right up in here how dark and tarnished this whole coil is, this tapped coil, and then if you look here how shiny it is right here, basically what I've done is I've taken just this little eraser and just lightly went over it, and you can see how much tarnish was really on there. And really, deoxit and chemicals like that will not clean this off. So I think really all that we need to do is do a good cleaning on this coil. I'm going to finish with the eraser, and then we're going to put it back together and kind of see if we made any headway here. And I'm also going to go through all the solder joints and make sure they're all touched up and that there's no problems with them. But other than that, we'll see what happens. All right, looks a little bit cleaner, doesn't it now? Yeah, that was badly tarnished, so I think this may have been part of our problem all along. So I'm going to put it all back together, and let's take a look and see if this took care of our FM problem. But if you've never seen this before, I know I haven't, this is your FM tunable coil, and you can just see the way it's made here, these tracks. It's an inductor, and it's a tapped coil. Really ingenious. I think it's pretty cool. So let's get it together and see what it does. We have it all back together, and of course, being somebody who really doesn't like stringing dial cords, I came up with just wrapped some black tape around everything and kind of put it in place. And I put a little reference mark here on the shaft, and I put a little reference mark on here. And we can just go ahead and put this thing right back together how it is. And I'm going to slide that back together, pull my tape off, and if all goes well, I think we should be in good shape. So let me do that off camera here so I don't have to reach around the camera. And we'll be able to turn it on and see if, if we fixed it. All right, everything's wired up again. So let's turn it up and see what we hear. There's negative 70 dBm right there. You can see we can still tune it right in. So yeah, I think we're going to be okay here. That's looking good. So let's put the radio back in the case and let's see. Let's just see how it works. Well, here we are. Looks like got her working.
You think I don't notice your pesky blackheads? It's all I see.
Now, I'm not going to get a whole lot tonight, especially down here in the basement. But some of the local stations it'll pick up.
So go ahead, snap away. With Biore,
Now, one thing I will say, I'm not going to get too much else down here right now, but one thing I will say is that this, a lot like a lot of the other old radios in their day, they tend to put tone control. Well, if you look here, I think on this one, this is where it is right here. If you look, they put right on the input grid of the output tube, they put like a capacitor network on there, like a capacitor resistor network, and it actually snubs off the treble and kind of gives you that muffled sound. Now, I don't know if that's because they like the radios to have a deeper sound at the time, but this is a pretty common thing, and you can remove some of this stuff and make the sound a little bit brighter. So, if you really wanted to mess with it, you could do that. But it's working, and everything's good on this radio now. So that's what it was. It was just the dirty contacts on this tapped coil right here. And like I said, this was an interesting little project because I learned something. I'd never seen anything like that before. So again, I hope you enjoyed this little video and our little repair. And I thank you for watching, as always. I thank you all for the good comments and all the kind words. And I wish all of you the best of health, peace, joy, and happiness in your lives. And I thank you for everything. And lots of more videos to be coming here soon. So, and until then, take care and thanks again. Bye-bye.